Hello, Assalamualaikum guys. Today is our final lecture. Okay, I'm like so happy. I don't know why. Yelah dah habis kan my part. So I should be celebrating after this inshallah. Okay. Alright. Okay, so this week we are going to look on the approximation of binomial and Poisson using normal distribution. Okay, so a little bit of introduction on why should we approximate. So last time when we do not have the technology, we do not have the calculator that can calculate the for whatever value of n and p. Okay, back then we need to use the statistical table, and the limitation about the statistical table is that you only it only gives certain values of n and also p. Okay, so but nowadays it's no more relevant, I suppose so, to approximate unless you have constraint lah to get the exact distribution. So per se memang you guna calculator lama kan, so you don't have that ability to get the exact distribution, then only you approximate. Okay, statistician we all would investigate on the shape of the distribution usually, okay, before we do some sort of approximation. So per se that on your left hand side is the histogram for number of successes. Okay, katalah n equals to 10. Alright, so as you increase the number of your trial, okay, so hence your number of successes will be increasing. Okay, so and per se yang ni you get n equals to 50 lah. Alright, so you will realize that for a large enough sample size or the number of trials, okay, so ataupun kata X is the number of defective items, so as you take more sample, okay, your distribution or your histogram, okay, would resemble the shape of normal distribution. Okay, alright, similarly, so if you plot on the Poisson distribution, okay, you akan dapat the graph as the lambda increases kan, dia akan really look at dia akan resemble, dia akan getting close and close to a normal distribution, the shape of normal distribution. Okay, the topic of approximation dah memang well explored. So they came out with a rule whereby if you have NP greater than 5 and P in between 0.1 and 0.9, then the normal distribution can be used to approximate the binomial distribution such that X will follow normal. Sebab normal you need two parameters, which is mean and variance. But what are the mean for how do you get mean out of binomial? So you boleh dapat NP lah. The variance you can get using NPQ. Okay, so this is for binomial. Okay, so kalau for Poisson, your mean will be lambda. Okay, and sama juga lambda will be equals to your variance. So this is when you have Poisson. Okay, so that's how you get the parameter of normal distribution from the bino or Poisson distribution. Okay, so it has to satisfy this one for binomial. Okay, and also for Poisson you need the condition of lambda greater than 30. Okay, just bear in mind that different books might have slight difference on the condition lah. So some books dia akan ambil lambda greater than 20. Okay, so this book ni dia memang macam play safe lah. So dia nak really seriously memang exactly the same with normal distribution. So dia memang ambil the largest lah, which is 30, bukan the largest, dia ambil agak banyak lah, which is about 30 lambda. Okay, compared other books might use 20 kan, sama juga macam what we have learned in guna binomial kan, you boleh approximate binomial using Poisson distribution. So what would the condition? You need what? N greater than 50, right? Okay, so you need n greater than 50, NP less than 5. So this one, if you need to use Poisson to approximate binomial. Okay, so yang ni I've already given you in the MS Team kan. So now one issue might arise when you do the approximation of binomial and or Poisson using normal distribution. Okay, what kind of issue would arise? Okay, one thing about binomial and Poisson kan, okay, they are a discrete random variable, whereas for normal it is a special distribution from the continuous random variable. Okay, so now there's a gap between a random variable of a discrete and continuous, whereby kalau you ada 2 dengan 3 for a discrete, there's nothing in between 2 and 3 kan, atau you have 4 kan. Okay, so there's nothing between 3 and 4. Okay, so now how do you make a discrete variable to continuous random variable? Okay, so one of the ways that a simple idea that we can think of is to close the gap between 2 and 3. Okay, so what we do is that we call this method as a continuity correction. Okay, so all right, so this is the rule of thumb, but you really don't have to remember all this. Okay, so I'll give you an example. Okay, so per se you want to find px sama dengan 3. Okay, right now katalah X is binomial lah katakan. Okay, so it's X is discrete. Okay, so you probably this X kan the N is katalah 17, the N is 17. So you don't have a calculator yang whiz class the recent models, so you only have statistical table, but statistical table didn't give you the N equals to 17. So what you do is that if the conditions is met, kan, NP greater than 5 for binomial lah, P in between 0.1 to 0.9. So you can use the normal distribution to approximate your binomial probability. Okay, alright, so but before that you need to do a continuity correction. Alright, so to close the gap between because you want exactly 3 kan, but in order for it to be continuous, okay, you need to close the gap between 2 and 3. So what you do is that kan, for a continuity correction, because you nak guna normal, you need to make it X a continuous random variable. What you do is that you tambah you tolak 0.5 here, okay, and then you tambah 0.5 here. So you are in a way like closing the gap between 2 and 3 and 3 and 4. Okay, so that's what we do. Kalau you nak cari X equals to 3, what you do, you cari X in between 2.5 to 3.5. Okay, so but remember for a discrete random variable, bila you nak cari apa the area or the probability, kan, you need to integrate the function or your PDF, okay, and then you're going to get the area. So that's why you tak boleh cari X equals to 3 kan, there will be no area, the probability will be 0. That's why we make the continuity correction, so that you would have some sort of area or probability around the X equals to 3. Okay, so alright, now I'll give you another example. Per se we need Px greater or equal than 3. Okay, so Px greater or equal than 3 kan, you want to close the gap between, sebab you nak start greater than 3 kan, so you want to close the gap between 2 and 3. So what you do is that X ni you do a continuity correction, you buat X greater or equal than 2.5. Okay, sebab tu lah dia A minus 0.5. Okay, you somehow you 3 you minus dengan 2.5. Alright, so per se you want Px less or equal than 3. Okay, so you want greater than less than 3, you need to close the gap between 3 and 4. So what you do for continuity correction, you put it as X less or equal than 3.5. Sebab tu you kena tambah 0.5. And then if you want in between Px in between 2 and 4 lah per se. Okay, so you need to close the gap between 1 and 2 and 4 and 5. Okay, so you buat continuity correction. Dua ni kan, you need to close the gap 1 and 2, so you buat 1.5. Untuk 4 ni you need to close the gap between 4 and 5, you buat continuity correction as 4.5. Okay, alright, so let's move to one example. Okay, if you have binomial 80, 0.3, use the normal distribution to approximate the binomial distribution. Okay, so obviously n equals to 80 is not in the statistical table, so you can use the normal distribution. Okay, but yeah, for the sake of studying, you bila the question is asking you to approximate, then you buat je lah the approximation. But actually in a real situation, it is better for you to have the exact binomial distribution, sebab bila you approximate, there will be some error, there will be some deviation from the true probability, because it's approximation kan, you anggar kan, so it won't be as precise as when you use the binomial distribution, of course. Okay, okay, kita try the A ni. X equals to 14, you're gonna get X 14 kan, 14. I'll just draw this to make sure that you can see the concept clearly. So you need to buat continuity correction 30.5 to 14.5. Okay, so sebab you nak guna normal. Okay, normal, oh yeah, wait, before that you kena X tu you approximate guna normal. Normal will be 80 times 0.3. Your variance will be 80 times 0.3 times 0.7 lah. So X ni will be normal berapa weh? Berapa? Okay, so X will be normal 24 and 16.8. Okay, Alright, so since you don't have the statistical table for mean 24 and variance 60.8, you only have standard normal and 01. So we change X to Z. This is what we did as the last lecture. So you akan tukar Z, you tukar Z 3.5 minus mean 24 over no 16.8. This is actually the variance. So you punya standard deviation will be a square root of 16.8. Okay, so it will be square root of 16.8. The same thing on 14.5, you tolak me, which is 24 over square root of 16.8. Okay, so you will be getting Z in between at this point of time, kan, because you dah tukar kepada continuous. Whether you want to put equal sign ke no or not, it does not matter, because X is already a continuous random variable lepas you buat a continuity correction. So I memang malas, so I don't usually put the equal sign. So Z will be in between 2.318 and 2.562. Okay, so let's just draw the normal standard normal to get you an idea which area do we want. So this is 2.318, this is 2.5. You need the area in between. So what you do is that the probability of Z greater or equal than 2.318. You need to use a greater ni because the table give you the X greater or equal in order for you to use to get the probability. So you minus dengan P Z greater than 2.5. Okay, so you will get 0.00497. So it's in the book anyway. Alright, for B. Yang B ni, alah, macam B ni macam straightforward sangat lah. Tak nak lah. Okay, C. We'll do C. We want Px less or equal than 17. This one will be Px. You can buat continuity correction. Okay, so yang ni 17, 16, 18. So you nak less than 17, you need to close the gap from 17 to 18. So you buat 17.5. You kena tambah 0.5. Okay, from after the continuity correction, you change X to Z. Z will be less than 17.5 minus 24 over square root of 16.8. So your Z will be less than negative 1.586. Okay, so negative 1.586 from the standard normal graph, it will be on your left side. Okay, negative 1.586. Okay, so you need this small area on your left tail. Okay, but the statistical book doesn't give you the negative Z. Okay, so what you do is that you can get the property from a positive Z. Okay, so it will be Allah Akbar, PZ greater than 1.586. It will be similar. Okay, because you just want to find the property anyway, and it's symmetrical, so definitely it's going to be the same. So look at your statistical table. Z greater than 1.586, you're going to get 0.0559. Okay. Okay, D will be sama juga. It's symmetric. Yang F, F pun should be correct. Oh, okay. I think E will be interesting to do together. You have Px greater than 13. Okay, Px greater than 13. Remember, X is binomial, so it's a discrete. So X greater than 13 is actually greater or equal than 14. Okay, so but since we want to approximate normal X will follow normal 24 and 16.8. Just now, okay, we change X to Z, okay, by minus the mean, which is 24, dividing by 60.8, okay. Jap, lupa. You need to change to, you need to do the continuity correction dulu kan. So, Px greater than 14, so 14, 15, 16, but you need to close the gap before 14, which is, you do continuity correction, you buat 13.5, okay. Alright, so it will be this one 13.5 lah minus 24. So you will get Pz greater or equal than negative 2.562. Okay. Alright, so when you look at your standard normal, negative is on your left hand side, negative 2.562 is here, but you want Z to be greater than negative 2.562, which is you want the whole big area here. Okay. But in your statistical table, it gives you the small tail kan, okay? So this one will be equivalent to what? Macam mana? 1 minus, this is equivalent to 1 minus Pz less or equal than negative 2.562 kan? Betul tak? Okay, but you can look at the statistical table for Z less than negative 2.5, and you know that Z less than negative 2.5, okay, would be equals to Pz greater than 2.562 because the standard normal is symmetric. Okay, so you look at your table, okay, you will get 0.00523 kan. Tadi kita dah cari dah kot. Tak lah. Okay, so you will get 0.99477. Okay, so I think the rest of it Oh, buat lah. Yang H tu probably a little bit tricky. Tak boleh kita buat je lah. Yang H. H. You want PX in between 13 and 29. Okay. So less than 29 is actually PX in between 13 and 28 kan, sebab you nak less than 29. Okay, 29 is not inclusive. And then here you need to do continuity correction dulu. Okay, sebab you nak guna normal kan tadi. X is binomial. Okay, so X after continuity correction will be, you nak close the gap between 12 and 13, so you dapat 12.5. You want to close the gap from 28 to 29, you jadikan dia 28.5. Okay, so after the continuity correction, you can use the standard normal. Okay, Z. So your P Z ni will be in between, yang ni you tolak dengan mean, you over standard deviation, you akan dapat negative 2.806. Yang ni will get negative 1.073. Okay, so when you draw the standard normal, aku buruknya aku punya normal. Okay, sorry, you will get, this one is positive, sorry, this one is positive. So standard normal 0 here. 1.073 is on your right hand side, negative 2.806 on your left. So you want this area in between. Okay, so yang ni sama jugalah macam Z kan. Okay, so what you can do is that all the probability you tolak dengan P Z greater or equal than 1.073, and you tolak lagi dengan P Z less than negative 2.806. Okay, but this one again, you cannot, if you want to use the statistical table, you kena put in Z greater, but you know that this is symmetric distribution, so whatever Z less than negative 2.3 will be sama dengan P Z greater than 2.806 kan. Okay, symmetric, so yang ni is the same thing lah, then 1.073. Okay, so nanti you will get your answer as 0.85522. Okay, so that's how you use the normal to approximate the binomial distribution. Okay, alright, so let's have a look at another example. So here you have a Poisson. X is number of counter opens. Okay, ni hypermarket kat mana? Kat Ion Big lah kot. Okay, so X will follow Poisson. Okay, average mean lambda equals to 40. Okay, on a specific day, what is the probability that there are less than 35 counter open? So you want to find Px less than 35. Okay, but I think Poisson 40 tak ada dalam table. Okay, so you try to approximate, you can approximate using normal distribution. So since your, oh ya, tadi kan, sorry, yang just now yang ni kan, we need to check lah the condition kan. Your NP is berapa? Okay, so your NP tadi is 24 kan. Okay, 24 is greater than 5, so that's fine. P must be in between 0.1 to 0.9. Okay, so this is fine as well. So that's why lah kita boleh guna approximation kan. So here, since your lambda is greater than 30, okay, so we can use the normal approximation. Okay, okay, but before that, X, you want X less than 35. This is X less or equal than 34 actually. Okay, so if you want to use the normal approximation, so X would follow normal mean lambda, which is 40. Your variance also 40. Okay, alright, so you do continuity correction dulu. Okay, don't forget that you're closing the gap between 34 and 35, so you're going to get 34.5. Okay, so after you do the continuity correction, you can use you change X to Z. So Z will be less or equal than 34.5 minus 40 over square root of 40. So you will get PZ less or equal, so you get negative 0.869. Okay, but dalam table pun ada 2 decimal je kan. You buat 0.87 okay juga kan. Okay, so you look at your table. Yang ni will be standard normal negative 0.87 kan here. So it will be equivalent to PZ greater than 0.87 kan. Okay, so you cari on your table lah. I think the value is 0.1923. I put buku je lah, bukannya I tengok pun. Okay, alright, so this question ni nanti kita do in the last session. Okay, so that's all for this week. Yay! Okay, but you have another big topic with Dr. Farida. It's on the matrices. Okay, although the matrices it doesn't blend well sangat with the statistics or the rest of the topic that we have learned in the second semester, but I think dia macam matrix ni it's somehow you need that information lah. You need to have the knowledge about matrices as well. Bila you deal with data, so data kalau ada banyak kan, big data, you need to put all these data into a matrix. Okay, that's all. I do not want to take more time on the video. Okay, so appreciate whatever you have learned so far. Please remember me in your dua. I will always remember you guys. You guys are always in my prayer as well, inshallah. And then thank you so much for your interaction during the live session, and I really appreciate that. Thank you. I'm gonna miss you guys, definitely, but I'm also happy to, because I've done my part already. I can focus on my research and my master students, PhD students. So keep in touch. I'm on the Instagram, so yeah, keep in touch, and all the best to you guys. Bye. Assalamualaikum. I love you guys.